To students, we're going to finish our second part series of our solving systems of equations. But today we're going to solve systems of equations using the method algebraically. That's actually using two different methods. So yesterday you saw graphically. Today we're going to do it algebraically. So we're going to look at two separate methods today. First, the substitution method, and then we're going to look into the elimination method. So with both methods, you're going to see some substitution, but elimination will eliminate a variable. All right, so let's look first at our substitution method. So it says use substitution to solve the systems of equations. Now you'll remember I said in the last lesson that if I'm missing two variables, then I need to at least have two equations. So I indeed have two equations. Now, what I'm going to do is I'm going to look at what I have and I'm going to figure out which variable looks easiest to solve for, because it doesn't matter which equation that I start with. So if I look at both equations, I think that this x is going to be pretty easy to solve for. So I'm going to start with that second equation, and I'm going to make that x equals 5y when I add it over minus 10. All right, now, since I used the second equation to solve for x, now I'm going to utilize the first equation. So I always have to go to the second equation of what I didn't use. All right, so I'm going to go back to equation 1. Now what I will do, instead of using x, I'm going to replace that x with 5y minus 10 from equation 2. And then I'm going to complete that equation with plus 4y equals 26. So you can see all I did was take this and substitute it for the x. So that gave me 5y minus 10 plus 4y equals 26. Now I have one equation with just one variable. Now I have a couple y's in there, but I can simplify that by collecting my like terms. So I have 5y plus 4y. That gives me 9y minus 10 equals 26. Now that's a nice and simple two-step equation. I have 9y equals 36. That must mean that y is equal to 4. Now I'm not done because I still need to go back and figure out what x is. But when I do this last step, I'm going to use the first equation that I solved for x and resubstitute y. So if x is equal to 5y minus 10 and I know y is 4, I'm going to replace that. So x is equal to 5 times 4 minus 10, or x is equal to 20 minus 10, and that gives me x is equal to 10. So the ordered pair that satisfies this system of equations is 10, 4. Now what's nice about these equations are I can always check my solutions very quickly. So if I plug in 10 plus 4 times 4 gives me 10 plus 16 or 26 into the first, and I do it in the second one, 10 minus 5 times 4 is 20, would give me negative 10. That also works. So I see that once again I get a consistent independent solution by substituting. All right, so let's try this real life problem using substitution. So we're looking at a furniture store selling two different types of chairs. A rocking chair that costs $265 and an Adirondack chair. And if you don't know what an Adirondack chair is, it's those colorful chairs that you see at the beach with the tall backs. Usually they're wooden, but sometimes you'll find them in plastic. All right, so the Adirondack chair sells for $320. The books show that last month the business earned $13,930 altogether for selling 48 total chairs. How many of each chair were sold? So what I don't know is both how many rocking chairs were sold, and how many Adirondack chairs were sold. So you can see that I'm just using variables that make sense in my equation. So the first equation that I'm going to build is based off of the prices and the amount that they made. So if every rocking chair was $265, it's going to be 265R, and each Adirondack chair was $320. That's going to give me 320A is equal to a total of $13,930. Now my second, remember I need two equations, so my second equation is going to be built off of the fact that 48 total chairs were sold. So that means the number of rocking chairs plus the number of Adirondack chairs is going to equal 48. All right, so now I've built my two equations. To use substitution, I'm going to look at the equation that looks like it's a little bit easier to solve. So I'm going to start with equation 2, and I'm going to take equation 2 and I'm going to solve for r. Now you can solve for a, it doesn't matter. I'm going to solve for r. So that's going to give me 1r is equal to 48 minus a. Now I'm going to go back into equation 1, and everywhere I see an r, I'm going to replace it with 48 minus a. So that's going to give me 265 times 48 minus a, replacing that r, plus 320a equals 13,930. Now you might need your calculators for this, and you might need to pause for a second if I go too fast. But we're going to take 265 times 48 because I need to distribute. And that's going to give me 12,720. Then I have 265 times negative a is negative 265a plus the 320a is equal to 13,930. All right, so now I have one equation and one variable that needs simplified. So I'm going to combine these two like terms. Using my calculator, I'll take negative 265 plus 320, and that's going to give me a positive 55. So I'll have 12,720 plus 55 A's is equal to 13,930. Then I'll subtract 12,720 from both sides. That will give me 55A is equal to 1,210. When I divide both sides by 55, I get that 22 Adirondack chairs were sold. Now, very quickly, I can figure out how many rocking chairs if I throw this right back up into this equation. So I'm going to take my rocking chairs is equal to 48 minus 22. And I'm going to find that there were 26 rocking chairs sold. So Lancaster woodworkers sold 26 rocking chairs and 22 Adirondack chairs to create to sell 48 chairs altogether and make a profit of $13,930. So those are our two examples of solving systems of equations using substitution. Now I'm going to move on to the method that uses elimination. Now my goal when I'm using elimination is to do just what it says. I want to first eliminate one variable. And then I use my equation to solve for the other. So again, I always need two equations if I have two unknowns. Now what I see is I see x's, I see 2y, a y, a 10, and a 6. Now I'm worried about this left-hand side, and notice that they're putting these equations in standard form. That's the easiest method to do this, to make sure your x's, your y's, and your constants line up. So now what I'm going to do is I'm trying to find a method to add these two left sides and right sides together. But if I do that right now, I'd end up with 2x, 3y's, and 16, and I didn't eliminate any variables. So what I'm going to do is I'm going to take this whole entire second equation and I'm going to multiply the entire left side and the entire right side by -1. -1 to the left, -1 to the right. Remember, whatever I do to the left, I must do to the right to keep my equation equal. That's going to give me a -x, a -y, and a -6 for my second equation, and I'm going to leave my first equation alone. Now, why I do this is if the left side and the right side are both equal, I should be able to add everything together and keep that equality intact. But another reason I do this is so that I can eliminate. When I add x to -x, it eliminates to be 0. 2y plus a -y gives me 1y, and 10 plus -6 is 4. So you can see very quickly that found for me my second variable, which is y. Now, like I said before, once I've eliminated one variable and solved, I'm going to have to use substitution. I'm going to substitute that y equals 4 back into either equation. It doesn't matter. Since the second one looks easier, I'm going to go ahead and plug that in there. So I'm going to replace this y with 4, and I'm going to solve for x. That's going to give me x is equal to 2. Nice and simple. So that would make my solution set be 2, 4. And I could do a quick check of this. So 2 plus 2 times 4 would give me 2 plus 8, which is 10. And 2 plus 4 is 6. So it checks. So I have a consistent and an independent solution. All right, let's look at another example using elimination. Now you can see with my two equations that I'm given that I don't have a quick let's multiply everything by negative. So this time what I'm going to try to do is I'm going to try to get a pair of coefficients to be opposite values, so one positive and one negative, but they have to be the same so that they cancel. So a 2 and a 5 will add to be 7. That's not going to work. But since these two already have a positive and a negative, what I'm going to do is I'm going to try to make these numbers be the same. So in order to do that, I'm going to have to do two multiplication problems. I'm going to have to multiply the whole top equation by a 2. So you can see what I'm trying to do here. Maybe I have 4x plus 6y is equal to 24. Now don't forget to multiply that 2 by that right side. That's a mistake I always make if I'm going quickly. Now I need to make the denominator be a negative 6y. Well, not the denominator, but the second equation. So I'm going to multiply this by a 3. Whole thing, left and right. So that's going to give me 15x minus 6y equals 33. Now you can see I'm going to be able to eliminate these with a quick addition problem. So when I eliminate this one, I eliminate my y's. I have 19x's total is equal to 57. And when I divide both sides by 19, I find x is equal to 3. I'm only half done, even though I did the majority of the work. Now I'm going to take this and plug it into either the first or the second equation. Now I'm going to go with the first one this time. Doesn't matter. I'm going to plug 3 in for that x, plus 3y equals 12, and now I'm going to solve for y. So that gives me 6 plus 3y equals 12. Subtract my 6. And I end up getting y is equal to 2. So my solution set is that x is 3 and y is 2. Now since I know that it probably works up here, I just used that one to solve. I could just check with that second one. So I could do 5 times 3 is 15 minus 2 times 2 is 4, and 15 minus 4 is 11. That's what's nice about these problems. You should be able to check every one and know that you got the right solution. All right, let's look at our last example using elimination. So this time I have two equations. The first one is negative 3x plus 5y equals 12. And the second one is 6x minus 10y equals negative 21. So you can see in both of them I have a positive and a negative, so I don't have to really worry about that. So let's just try to get rid of the x's. So I'm going to multiply the top one only by 2. That'll give me 6's. So that's going to give me negative 6x plus 10y. Don't forget that right side gives me 24. The second equation I'm going to leave alone. Then I'm going to go ahead and use my equality property. And when I do that, my x's are going to eliminate, but also my y's, leaving me with 0 on the left-hand side. Now, if I have 0 on the left-hand side, I need to have 0 on the right. However, I have 3 on the right. Well, 0 can't equal 3. That must mean that no solution would ever work to satisfy these two equations. That must mean that when they were graphed, they had the same slope, but they had different y-intercepts. So this would have been a solution set that was inconsistent if we went to categorize them. So this guy would give me no solution. Now just to warn you a little bit, if I would have ended up getting a 0 here, so say this ended up being 24 and I ended up getting 0, what that would have meant was that these two equations were actually the same equation, which meant that they were the same line. And that would have changed my answer from no solution to infinite number of solutions. All right, so you might see that in your problem set tonight. All right, check on Google Classroom for your assignment to practice some more of these problems. Have a great day.